now we're getting into 11.6. 11.6 is the last lesson we have to get done before Christmas break. It's not that we're going to leave volume after Christmas break. We're going to jump back into it after Christmas break, and we're going to add to the volume of cubes and rectangular prisms also things like triangular prisms, cylinders, and more in-depth geometric shapes. Then we're going to get back into inequalities, which I introduced to you in Chapter 10 in those extra lessons. Now, if you realize or paid attention in the last video, then I kind of stammered on which words I used. I've trained myself a long time ago to not use the word base when I'm talking about finding volume, but it really is an interchangeable word for length. You know, as we looked on all the different formulas for area. We had base times height, or base times height divided by 2, or base 1 plus base 2 times the height divided by 2. So we use that word quite often for an interchangeable word of length. But you're going to see some problems on here where base means something a little different with a three-dimensional shape. And I didn't want it to be confusing. The only thing you need to understand is if I have the three measurements, and it is a length, a width, and a height, or a base, a width, and a height, and I can do them in any order. I've said it several times in my videos, but that's the associative property of mathematics. And associative property of mathematics means that if it's all addition, if I have 2 numbers, if I have 3 numbers, if I have 100 numbers, and I'm adding them all together, I can mix them around in any order that I want, and I'm going to get the same answer. Same with multiplication. Let's say you want to start with your width. Then you want to multiply your height, then you want to multiply your length. It doesn't matter. Because it's all multiplication, I'm going to get the same answer. So I may say it in a different order, but once again, it doesn't really matter. Reviewing what volume means, once again, volume means that I'm going to take my three-dimensional shape and I'm going to fill it up. So how much does it hold inside, or how much will go into the shape? So that was 11.5. Introduce the formula, and now we're going to work with the formula over and over again. Notice I boxed in the B on this side for the base, because that's the one that gets a little tricky when I see a couple of these problems, because base really can mean something different when it comes to the three-dimensional shape. Let's get into what we're talking about once we also get through then the algebraic equation. That worked through a couple of you the other day, and it's not a difficult thing. Now, if you saw some of the math that I used to do when I was a math major, with trigonometry and analytical geometry and Euclidean geometry and finite math, then you should get concerned, because this is a level of algebra that is extremely difficult even for people who major in mathematics. But let's take it down to your level. A plus 3 equals 7. That's algebra. Well, how is that algebra? Algebra just means that I have either an equation or I have an expression. And an equation, once again, it has an equal amount, it has an answer to it. An expression means I would take that 7 off. I could just have a plus 3, and it gives me an expression in what to do. But equations have answers. Algebraic equations could have answers, could not have answers. They involve numbers. They involve mathematical operations, and we have 4 of those once again: adding, subtracting, multiplying, and dividing. And they involve variables. And variables is not a tricky word, it's just a big fancy word. You're also going to use that exact same word when we start getting into science after Christmas break, talking about the scientific method. Variables in math just means a letter. It can be any of the letters, or even symbols when you get into the Greek alphabet and you want to use those. So let's break this down and look at it real quick. Is it algebra? Well, it is an equation because I know it's equal to 7, so it has an answer. When I look at the next thing, then it says numbers. Yep, I have a 3 and a 7. And then a mathematical operation. Yeah, it's addition. And it has a variable. It does have one, the variable a. That is indeed algebra. You've been doing algebra since 3rd grade. Because you were in Saxon Math in 3rd grade, and when I taught 3rd grade 21 years ago, teaching Saxon Math, we use letters to introduce some of our math problems. Well, how about this? It's my formula for volume. Is it also an algebraic equation? Well, I know it has an answer because my volume is what the answer is going to be. I don't see any numbers though, but my operation is multiplication because a letter touching a letter or a letter touching a number means multiplication.
and I have the length, the width, the height, and the V for volume, it is algebra. But what about the numbers? So let's look at what this first problem asks us about in the book. I just want to think about it, and then I want to discuss it before we start filling in the book so we truly understand what it's asking about. There's some of the stuff that we can start figuring out as we're reading it on how we're going to show our work. It says you can use the formula V is equal to L times W times H. Algebra equation just means that volume is equal to the length times the width times the height. And I have this information. Well, if I use the formula length times width times height, and I know that an algebraic equation has to have numbers, where do my numbers come from? Well, they came from this rectangular prism, didn't they? So down at the bottom, I have my length, I have my width, I have my height. My length is 5, my width is 4, and my height is 2.5. So I'm going to use that, and I want to then do my math. So algebra, formulas, equations, all it means is to plug in the number that you can figure out, or the number that is given, into the place of that letter. It's not as difficult as it appears. We're just not used to seeing a lot of math set up that way. But once I plug that in and I start looking at my information, I know I have those three multiplied together. The first thing I should notice is I've got a mixed number there, don't I? I can't use a mixed number. Once again, going through those steps, I set up my mixed number. I start at the bottom. I multiply and add. So 2 times 2 is 4 plus 1 is 5. And my denominator stays the same. So it would be 5 halves. And then when I look at that, and it's a fraction in my math problem, then I know I also am going to have to change my two whole numbers. So I know I'm going to have 5 over 1 times 4 over 1 times that 5 halves that we just converted into an improper fraction. I'm going to cross reduce when I do my math because 2 goes into 2 one time and 2 goes into that numerator of 4 2 times then, and then that would leave me with multiplying across to get my final answer. 5 times 2 times 5, well 5 times 5, associative property, any order I want to do them in, is 25, and 2 quarters, 2 groups of 25, gives me 50. My denominators of 1 times 1 times 1 just makes it equal to 50, and then my labels are cubic inches. I went through that quick because I wanted to talk about, now we're going to fill in our book in the order that they talk about. So it says that my length is 5, and what is my width and what is my height? So when I look at the information they give me, well, my width is 4, my width is from front to back, my height is 2.5 going up. Now if you would accidentally put those in the wrong area, that would really be fine because mathematically when I plug them into my math, I can do them in any order that I want to. So when I look at converting my mixed number then, I have to show that work. So I need to have on my paper 2.5, starting at the bottom, multiplying, so 2 times 2 is 4, adding the numerator of 1, which is 5, and then I keep my denominator. So I'd end up with 5 halves. So when I plug it into this line down below, I have a numerator, 5 over 1 for my denominator, a numerator of 4, and then a denominator of 1, and then 5 halves, which we converted. And then we would cross reduce. The 2 would go into the 4 evenly because they're both even. I'm going to do that as often as I possibly can to make my math easier, but we're going to see a lot of problems on this math lesson. It's not that easy. They're just going to be some really big answers. I'm going to end up with my numerator of 50 over a denominator of 1, which tells me that I have 50, and once again, cubic inches has the exponent of 3, because multiplying length, width, and height is 3 things, so I put a 3 on my label. So let's look at this one then. I have this prism. I'm still going to use length times width times height. It says the height h is what? Well, the height is 2 1/4, right? So I'm going to plug in my 2 1/4, and then it says the area of the base is 9. So that's why we don't use the word base a lot when we're talking about the formula for volume, because length to base when it comes to a flat shape really does mean the same thing. But as we talked with surface area in chapter 10, base means the bottom and top of a three-dimensional shape. So here they're telling me that the bottom rectangle of that rectangular prism has an area of 9 square inches. So if I know the base is 9 square inches, that bottom layer then I'm just going to have to multiply by the height to do my last step. Because they're showing me then my volume is base times height. Well, the base in this situation is already a length and a width, isn't it? It would already be this length and this width multiplied together. So they've already done the first step, the first multiplication problem for me to get to the right answer. Area, once again, is base times height, which they've done for me, which would have been my length and my width, or my length and my width for my overall shape. It's just talking about that bottom rectangle. So now I got to do the height. Once again, it's a mixed number. I have to make it an improper fraction. So I have 2 1/4. Start at the bottom, multiply and add. 4 times 2 is 8 plus 1 is 9. Keep my denominator of 4. So I'm going to take my 9, which is my overall area for my base, and I'm going to multiply by the 9/4 that I have for my height. When I put my 9 over 1, since it is a whole number and multiplied by a fraction, then that leaves me with 9 times 9 going across and a denominator of 1 times 4, which is just 4. So when I look at my volume, I have 81 over 4, but then I have to either reduce or convert into a mixed number, whichever is going to work for this problem. Maybe both. When I do the division, I see that 81 divided by 4 is 20 as a whole, and a remainder of 1. And once again, to make my mixed number then, when I have 1 as my remainder becomes my numerator, my divisor stays my denominator. So what I'm left with is 20 1/4. 20 1/4 what? 20 1/4 cubic inches. On the next problem then, they give me a cube. And notice this fancy formula up here. The volume is equal to s cubed. Well, they kept showing us that volume for it, or area for a cube, was s squared, because it was two sides that were the same, because they're squares. It works the same way. All that is saying when it is a cube is length times width times height. So when I go to my cube that is 3.5, I know that I have to change that into an improper fraction. So I start at the bottom once again. I multiply and I add. 3 times 2 is 6. 6 plus 1 is 7. I keep my denominator. So my new fraction that I'm going to use is 7/2. I'm going to have to use 7/2 how many times? Well, once for the length, twice for the width, a third time for the height. I have 7/2 times 7/2 times 7/2, and then I'm going to multiply those together. And how do I multiply fractions? Multiply across. So I have 7 times 7 times 7, and my denominator I have 2 times 2 times 2. Once again, our minds get ahead of us sometimes, and we may put down that that's 6 as my denominator, and it's not. My numerator is not 21. It's multiplication. So on my handy-dandy calculator, I would type in 49 times 7, because 7 times 7 is 49, and I'm going to find out that that's 343. That's a bigger number. And then I have my 2's. 2 times 2 is 4, and 4 times 2 is 8. That's why it's not 6. So then I'm going to divide. Notice I didn't cross-reduce anything, because all I have down here is even numbers, and at the top all I have is odd numbers. There isn't anything to cross-reduce. I'm just stuck with working with those bigger numbers. I can still do the math. It's still straightforward division that we've been doing since 4th grade. 343, my numerator goes inside the box, divided by my denominator. So I have 343 divided by 8. 8 goes into 34. 4 times 32. Subtract them. 34 minus 2. 2. I bring down my 3. I'm left with 23. 8 goes into 23 2 times, which is 16. 16 taken from 23 gives me a remainder of 7. So then I have to know how to write my mixed number as an answer. My whole number is 42. My remainder is my numerator. My divisor, once again, is my denominator. So my final answer is 42 7/8 cubic feet. Now I may have gone a little fast for you, and that's fine. Just pause the video and get it written down so you understand it. Even rewind as many times as you need before you go on. We get into our share and show. our introduction is really quick on this lesson because it's just applying the formula that we learned in the last lesson into this one. We're going to have 5 different problems we're going to work through, and every single time we're going to take my length times my width times my height. So when we look at the first one, I have 3 different measurements. I have 10 and 1/2, 15 and 25, all with the label of inches, and I know I'm going to have to multiply those together. Well, it's the 10 and 1/2 that throw me off because it's not a whole number, so I know I have to change it, which makes me change my 2 whole numbers that I have left. So 10 and 1/2 changed into an improper fraction. Start at the bottom, multiply and add. 2 times 10 is 20. 20 plus 1 is 21. My denominator 2 is going to stay the same. So I know I'm going to have 21 over 2. And then in order to use my whole numbers, I have to put them over 1 for my multiplication problem. So 15 goes over 1. 25 goes over 1. I cross reduce if I can. And when I look at it, I have 2, which is an even number. Doesn't go into any of them at the top. They're odd numbers. And 1 doesn't go into anything with changing it. Goes into everything, but nothing changes, so there's no point trying to cross reduce with my 1. So that leaves me with just doing some big math, doesn't it? Handy dandy calculators are very handy and quite dandy. So I'm going to multiply across. I'm going to multiply and type it in. 21 times 15 times 25 equals 7,875. Big number. Nothing I can do about it, but I can do my math to get the right answer. 2 times 1 times 1 is 2. Pretty straightforward math, pretty easy. Once again, numerator goes inside the division box, dividing by my denominator. So I have 7,875 divided by 2. And when I divide that all out, you may pause the video and show the steps. But when I have 7,875 divided by 2, I get 3,937, remainder 1. So once again, I have to know how to write my mixed number in my answer. I have 3,937. My remainder is my numerator. My divisor stays my denominator. So I have 3,937.5 cubic inches. That label's already given there for me, so I don't have to worry about writing it. But from this point forward, I have to write it to get a right answer. So on number 2, I have a smaller cube. 3/8 of an inch for each side. I could do side to the 3rd power, which would be to multiply the side by the side by the side, since it's a cube and all squares have the same sides. Or if I just remember it's length times width times height, it's a little bit easier and one less formula that I have to know. But I set it up and multiplying all 3 together, so I know I'm going to have to fill in those 3 spots. The fractions are straightforward, so I don't have to worry about having to convert them. My numerator is already smaller than my denominator, so I'm going to see what I can reduce. Nothing. 3 won't go into 8 evenly, and those are my only 2 numbers that I can use. So I'm going to multiply my fractions across. 3 times 3 times 3 is 27, and my denominator of 8 times 8 times 8 equals 512. If I can't reduce in here, then most likely I'm not going to be able to reduce over here. I can't reduce. My only factors for 27 are 1 and 27, which won't go into 52. 3 and 9, 9 and 1 go into 512. I said 52, I meant 512. So I'm just going to simply write my answer as 27 over 512. That would be said 27 512ths. Not a number we would say very often, but we'd still write our answer correctly and add my label of cubic inches. 3 exponent, because I multiplied 3 things together. So my last 3, I have number 3, which gives me 3 measurements that are all mixed numbers. So all 3 I have to change into improper fractions. So I'm going to do the work. I'm always going to start at the bottom. I'm going to multiply and then add and keep my denominator. So when I do that to all 3 of them, then I'm going to get 2 times 8 is 16 plus 1 is 17. 2 times 6 is 12 plus 1 is 13. 2 times 12 is 24 plus 1 is 25. Those are going to be my 3 numerators, and my denominators stay the same, and they're all 2. So I get 17 halves times 13 halves times 25 halves. Bottom numbers are even, so what can I cross reduce as in my numerators? Not a thing, can I? Once again, it's going to be a big number, and it's going to be a smaller denominator. So I'm going to multiply across in my handy dandy calculator, 17 times 13 times 25 equals 5,525, and then 2 times 2 times 2 equals 8. So I'm going to have a numerator of 5,525 divided by, so inside the division box, 8, which is my denominator. When I divide them out, 8 goes into 5,525 690 times. So you can pause the video and make sure that that information gets written down. Then unpause and notice that we have a remainder of 5. And once again, my remainder is my numerator, my divisor is my denominator. So I end up with an answer of 690 and 5/8 cubic feet. My label, once again, can't be feet, can't be squared. It has to be cubed because I multiplied length, width, and height, which gives me an exponent of 3. Number 4 is a cube, so I have my one measurement that I need. I could only have one measurement and the other two not even be there and still do the math because it is a cube. So I know I'm going to multiply the three things together, my length, my width, and my height. I have 5/16 times 5/16 times 5/16. Once again, nothing that I can cross reduce. So I'm going to have to multiply my numerators and multiply my denominators. And when I multiply across, 5 times 5 times 5, 5 times 5 is 25, 5 quarters is $1.25. 16 times 16 times 16, I used my handy dandy calculator, 4,096. What will go into those two numbers? Yeah, absolutely nothing. So my answer is just 125 over 4,096 cubic inches. I'm going fast only because I want to try to keep the video under 30 minutes, but please, by all means, pause it, make sure the information is written down and you stay up, and then you can restart as we get into the very last one. So I'd like you to try number 5 on your own and see how you do. Pause my video now, restart when you're ready to go. So hopefully you have an answer, you have your work, and you think about it. Now I'm going to be honest with you as a teacher. I was working last night at 11:45 on this problem. Kind of tired because I had been up since 4 o'clock the Sunday morning doing the last video, and I kept getting the wrong answer. And I knew I got the wrong answer because I had my answer book for the teacher's copy. There's no way that they show work, so I had to figure out why I did the wrong answer. And when I finally stopped at about 11:57, I realized I kept using this as a measurement. And it's not a measurement. They gave you 3 numbers and they shaded in that end to try to trick you. And I know that they tried to trick me because I didn't notice at first that this had a square label on it. And it had a square label on it because they found the area of one of the sides. A little frustrating, but it is what it is, and it's a good learning lesson for you not to make those mistakes, even though we all make mistakes, but we can figure it out. So I know that they already did 2 of my multiplication for me. I don't have to know what my length and my width are, but if I took 3 1/3 and divide it by 1 1/3, I figure out what that other side was they multiplied together. But I'm just going to use the 3 1/3 times then my base, or my length. So my length is 6. So I know I'm going to take my 3 1/3, and I know I'm going to multiply and add, and then I'm going to multiply the length. So we had the width and the height that were done for us, and then we're going to have to multiply the length to find the volume then. So with the height and the width already done, then all I have to do is figure out how to change that into an improper fraction. 3 times 3 is 9, plus 1 is 10. Keep my denominator. So I know I'm going to use 10/3, and then I'm going to look at the last number, which was the length, which was not used, and the length is 6. And since I have a fraction, I know I have to take my whole number and put it over 1. So 6 over 1. Cross reduce any time that I possibly can. First one of these that I can actually do it on. 3 goes into 3 1 time, and 3 goes into 6 2 times. That leaves me with some pretty easy math to do to finish it up. 10 times 2 is 20, and my 1 times 1 gives me 1, so I know I have a whole answer of 20. I look at my labels, it's yards, I multiplied those 3 sides together, so I have cubic yards. So 20 cubic yards will be my final answer. So your assignment is going to be listed on your paper that you have, which is once again your ticket to go into the movies on Thursday. All of your work must be done and completed. If you didn't understand the lesson, then please go back and watch it again. If you've watched it, taken your notes, and you can show me in your book that you've taken notes, then please come and ask me questions and I'll help you all that I can. Once again, volume is just how much will go into it. And on volume, all I have to do is know my 3 measurements. I have to know my length, my width, my height, and then multiply them together. Some of them you're going to be able to cross-reduce, and I will cross-reduce every time I possibly can to make my math easier. But some of them, as we saw today, are just big answers. And you have to just use the big answers that they gave you. But always remember that on my formula, that I also indicates that I have a cubic label. Volume always has to have a cubic label. It doesn't matter if I'm finding the volume of a cube, a rectangular prism, or after Christmas, triangular prisms, or even cylinders. I have to have a cubic label because I'm going to multiply 3 things together. If you have any questions while you're doing your assignment, please come and ask.